Welcome everyone to Science Society, and a special welcome to both of you, Zoltan and Sandra. And before we start, let me give the audience very briefly where you're working. Professor Zoltan Nadasdy is associate professor at the Institute of Psychology and a lecturer at the Department of Cognitive Psychology and the head of the research group of Human Electrophysiology Research Group at the, now I'm not sure I'm going to say the name right of the university, at the Eötvös Laurent University.
That's fine.
Great, in Budapest. And Sandra Stojić, she is in Professor Zoltan's lab. So welcome both of you. And usually we start by interviewing our speakers so we get to know the two of you a little bit better, if that's okay with you.
Absolutely.
Of
Perfect.
course.
Yeah, thank you. So how did you and whoever would like to start first discover this interest for doing research, and how did you get to into this career or into this field? Was it something you always wanted to do, kind of a childhood dream, or was it something that came later through an experience, maybe a great class, or some family members that supported you? Thank you so much.
Well, thank you, Katrina, for the kind invitation. And it's really a pleasure to be here and talking to all of you. So I'm looking forward to get your questions. Briefly about myself, I actually live a double parallel life. So one of my life is in Budapest, part of the Eötvös Loránd University, as Katrina said. And my other half life is in Austin, Texas, where I'm also part of the faculty of psychology, and I mostly do neuroscience research there. So there's this. I have a dual interest. One is the cognitive or cognition, the development of cognition, and as well as human electrophysiology. But today we mostly going to talk about the psychology of time perception. And yeah, in terms of inspiration, I will be short. It's a long story, but I just want to cut it short. There's, all of us, or most of us, are inspired by somebody, or a few people. I blame my inspiration. I blame one person. It's Leonardo da Vinci, who had a tremendous influence on me, especially in adolescent time. I was totally preparing my career to be a painter. I went to art school. I pursued art. I took it very serious, and I studied Da Vinci's work, and I just wanted to be a better painter, and that took me to a little bit of like side project of studying a little bit vision. How do we see? How do we perceive the world around us? And that took more than just a little side project, because everywhere I went, I listened talks and talked to professors. I realized that nobody is taking me seriously unless I am committed to that field. So I actually put painting to the side for a while, and I went to the university and I started studying psychology, and I realized that you cannot really pursue that kind of life that Da Vinci impersonates. It's impossible today to to excel in art and science and all the field in music. So I had to take, I had to commit to something and prioritize. And that's, once you study, you became part of the academic community, you have projects, you have theses to write, you have all these milestones, then that leaves no time for anything else. So I got stuck in science. Sorry, that was the longer story that I planned to tell, but that's basically all these questions about vision, how do we see, and memory that really got me into psychology, and later on to the neuronal basis of all these functions. So I consider myself as a neuroscientist today. All right, that's enough for me. Sandra.
Yes, I'm here. Hopefully, you can hear me. Hello, Katarina, and greetings to your audience as well. And of course, thank you for inviting us. It's such a pleasure to be here. So, my story, it's not so different from Professor Nadasdy. I didn't know that we had so much in common, but I will just give a very brief introduction. So, my name is Sandra Stojić, and I did my PhD. Actually, I'm in my last year of PhD studies at Eötvös Loránd University in Budapest, and Professor Nadasdy is my supervisor. And I didn't lead this parallel life. However, I was traveling back and forth from my home country and Budapest, so kind of I can relate to his situation. And by the nationality, I'm a Croatian, so maybe you can tell by my accent or by my name. Why I was drawn to psychology? Well, first of all, I think that's a great question, and I can say that I was always interested to know how things work, and I had so many questions. Probably my parents hated me at that time, but I think that I can kind of pinpoint one event that led me into this direction. When I was in high school, my parents fulfilled my long term dream and probably my biggest childhood I wish, and they allowed me to have a dog. So at that time, I was so curious and willing to read every book possible and available because I was so keen to provide him like with the best doghood or childhood, if that's even the word. So I read most of the things that they were available to me at that time, and of course, most of those books they were coming from the field of psychology. So even though at that time I was officially trained to become a concert pianist, meaning that I went to gymnasium in the morning and to the music school in the evening, just right before the admission exam, I kind of changed my mind and I submitted my documents to the Faculty of Humanities and Social Science. So that was kind of my path, and I don't know what future holds, but I haven't regret my decision, at least not yet. And I also find interesting many overlapping areas such as biology and neuroscience, of course. But for instance, I was never attracted to psychotherapy, and I think it's such a shame that many people are misinformed, at least where from I'm coming, because whenever someone mentions psychology, they always instantly think of psychotherapy, and psychology is much more than that. So that was my kind of a path in a very short and brief version.
Well, thank you so much for sharing both of your stories. I wanted to welcome Dr. Roshanak. I think you know each other, so
Zolly.
welcome.
Who
Zolly.
is this? Sorry.
It's Ro. It's Roshanak. Do you remember?
Oh, Ro. Oh my
How are
God. Yeah,
you?
we haven't been.
We haven't talked in
Oh, I haven't
forever,
seen
and you
you
showed
so
up on
long.
the
Yeah.
app.
Wow.
Zolly,
Well,
I'll
thanks
just tell
for
you guys
being
right.
here. Yeah, we
I'm
should connect after this.
absolutely. I'm running my own room, and Katarina had pinged me in, and I did a double take on the name, and I went, "Oh my God, that's a." For all of you who are in this room, I've known this man for decades. He is one of the smartest people I have ever met. The guy's genius. You're so
Okay.
lucky to have him here. Honest to God.
Okay. Okay. Well,
So good to have you
yeah,
here,
I'm not sure
Zoe.
I will live up for that expectation.
You can't
Okay, but
argue.
yeah.
Well, thank you for that. And yeah, it's so nice to see that friends re-meet here. That's wonderful. And Yeah, thank you for sharing those stories. It's really interesting that actually quite a lot of speakers we have, they kind of have this had this life in art and science, and then kind of decided some people keep, doing it hobby wise. But it's really interesting, and it shows kind of that, the sort of creativity and interest and challenges are probably very similar. We just in modern times kind of separated fields in a very artificial way. Would you agree on that?
Yeah, absolutely. Yeah, it's well, I've been struggling to fulfill all my desires in this field, and this as everything is getting increasingly professionally streamlined and bureaucratic. It is really difficult to carve out the time and the part of the field of research that really uh, uh, enjoyable or make us able to enjoy it. So it's that's my constant struggle to maximize the time where I can do what I really enjoy and minimize the time that I'm tired and bored with it.
Yeah, I think that for me it's the same thing, and I struggle. I just do I just do things, although they are not probably good for my career, my future. But the thing is, if you want to, get a lot of grants and make a career in a specific way, it's almost impossible to do anything else. But I don't really understand because, also from NIH perspective, grants,
Yeah.
places, the future needs more creative, interconnected thinkers, and our lifespan where we are still able to work just increases. I think we have to change the model that you have to be in one field only. I think for, to adapt to our system to humans, we have to kind of change that because who wants to be 60 years just working on the same problem? That's ridiculous. I think so. I think hopefully in the future this will change.
Yeah, I agree. I'm in a constant battle with myself and arguing back and forth whether I should have, committed my life on just one topic, and I would be much more ahead in my career than, I would have 200 publications, and instead I have let's say 50 publications, but all those publications I 100% stand for, and yeah, not a line that I would change. So yeah, it's there is no recipe. I can't really give people a model or a template what to follow. It's um, it's really it's probably a large individual difference is how much one can take uh, from uh, from things that he or she doesn't like uh, as a profession or to pursue something. I just never wanted to pursue somebody else's desires in life. So that many times it's actually an obstacle in your career if you are pursuing your own personal goals.
Yeah, and the second question, really quick. I know we've been going a little bit, but it's a very interesting pre-discussion already. So the how did this project come about? Was it some, was there some struggle? Was it really, also easy to get funding
Mhm.
for? Is there some kind of backstory
Yeah,
behind?
yeah, there is, and thanks for resetting the conversation and just remind me for time and the topic. Yeah, which unfortunately we have limited uh, time, and it's so since the topic is time also, um, it Um, time is something that we all are. We can be neutral to it. This topics, all everybody can relate to because it's such a pervasive concept. It really transcends our life, and everything revolves around the concept of time. So I get interested in this question quite early on, and it was a kind of interesting story that this question of how do we perceive time goes back to my undergraduate college years when I was studying psychology in Hungary, and we had a project in the school that was a team project, and we had to select one. We had to conceive an experiment and execute it and analyze it, and that was our whole semester project. And I somehow convinced my classmates to do the project I dreamed, which was pretty much similar to this project. I wanted to know how kids perceive time relative to adults because we all have that experience that when we were kids, like 3 to 5, 6 years old, certain events like summer camps, vacations. The first time I went to the beach, to the sea. Um, these are retrospectively they felt so much longer than let's say the entire summer times today as an adult, as a grown up. So when we reflect on time, we have very distorted perspective. So what does make time feels sometimes very long, um, and other times very short, very compressed? What is that elasticity that that we experience with time? And so in our really simple experiment, we gave kids two video materials. We played two videos. One was a very eventful video. The other one was boring. Both of them were clips from cartoons. Sandra will explain this much more in details. And we asked the very simple questions from kids and adults. Well, which one was longer? Both video was exactly the same duration. Okay, and we just asked which one was longer. The main difference between the two videos is one was really eventful, really action packed, adventures. The other one was really boring. Nothing really happened. So I was curious how much the content uh, of these two experiences influence our reflecting on the time that it took, uh, and and well, we wrote this. So this became a school project. We wrote the report. Everything went fine. I moved on my studies, and I checked the literature like 20 years later if there is anything like this have been published, because I thought this is such a basic experiment that somebody will do it much better, in a laboratory with much more precise equipments. And I was surprised to see that it hasn't been done. So when Sandra came to me, and she seemed to be the right person with the right mind, and able to, you know, an analytic mind, was able to wrap her mind around all the complexities of this question, because time really relates to philosophy, psychology, neuroscience, even physics. So she seemed to be the right person. So we embarked on it, and she executed this experiment, which would actually deliver the results that we were expecting. And yeah, so that's the story in brief. How did we get to this study? And I'm still kind of surprised and awakening of what a big splash this study made in the science, because I get so many people writing to me and interviews, and it seems it's really cutting deep in people's mind. How I guess we are all, for the reasons I mentioned earlier, because we are all so much involved in managing our times, and time is really became a currency of our life, I would say. Yeah, Sandra, if you have something to add.
Yes, I'm here and I completely agree. I think one doesn't have to be a scientist because topic such as time or space, these are all very fundamental concepts and very uniquely human experiences. And I believe every curious person asks herself at least like sometimes during the lifetime, what is time and what is space? Like how do we experience those things? So I also agree with the Professor Nadasdy, and I believe it's very exciting to work on this topic because it's never boring. There's always something to read, something to explore, and also it includes a developmental, neurobiological, or philosophical perspective, even the physical, as he said. So it's never a dull moment here. So I'm actually very glad that it's my topic. And
Oh,
of
that's
course, we have
wonderful. Oh,
yes.
good.
No. I wanted to say that this is just one of the papers that we are working on. So it was just the beginning, but of course we are very glad to see the reaction because the paper went out in January, and I believe that it was downloaded maybe 3,000 times so far, and it still holds on the 50 position like among all the tracked articles. So it still goes in the 99 percentile. So it's very encouraging also for me because it's my first study that I ever published. So it's nice to see that people are reading and enjoying our work.
Well, congratulations for that, and I think you deserve all the attention. And yeah, so if you want to now dive into the presentation,
Of
for
course.
everyone,
Hmm.
the link is posted on top. And Renee, did you want to add a short comment before we go into the actual research?
Yeah,
No?
yeah, yeah. A couple quick comments.
Hmm.
For those who remember Alvin Toffler, Future Shock, I saw him when I was in McGill in the 60s. His concept of time, when you think of time being relative to a child that's going from 2 years old to 4 years old, that's doubling the time you've existed. So when you go from, say, 1 to 2, you've doubled. You go from 1 to 3, that's 3 times the amount of time. When you go from 20 to 40, of course it's going to go much faster or equivalently to 2 to 4. And so there's no, for me, it's so obvious as far as the relationship of how children versus adults see time. It's relative to how long you've lived. So it's very, very simple for me.
Well, Renee, if you would like to read the paper and wait for the researchers to actually share
Sure,
their
sure.
research, please, yeah, because
If
nothing is ever really simple. If you think anything is really
yeah,
simple,
if
then you didn't ask enough.
Yeah. No,
Okay, let's
the
go
other
if
ahead.
concept,
if
no, because I
if
might not be able to stay. So at least the last concept was Einstein. So when you're in pain, you really feel it for a long time. He actually said if you speak to a pretty girl, an hour feels like half an hour. And so if it's pleasurable, it goes faster. If it's painful, it goes slower. So there's different views. There's Future Shock, Alvin Toffler, there's Einstein, and there's a research study that I'll listen to.
Renee, if I can very quickly answer to your uh, challenging question. It's a really good question. Thanks for asking that. I was actually saving that to the end. Uh, I 100% agree with you that time is distorted. I mean, time perception is proportional to the total lifetime of the observer. And you mentioned that 2 years old is half the age of a 4 years old. 4 years old half the age of the 8 years old. Of course, the perspective on time, on let's say on the summer times and how intense the summer were, will be different. And as I said, I'm 100% agree with you on that. However, you will see that in our experiments, kids and adults will look 1 minute videos. So it's a relatively, well, not relatively, it's really short time relative to their age. So that effect that you mentioned, the total life lived, doesn't really matter or doesn't really confound our result. You will see. Okay, just hold
That's
that.
a good point. That's a good point.
Just hold that skepticism, because yeah. So what we're gonna argue for that, and Sandra will make this more clear, is that kids use a completely different heuristics to adult relative to adults, and we switch those heuristics somewhere around the age of 6, 7 at school age, which
Hmm.
and school will have to do something with it. But I don't want to spoil it for Sandra. So
Okay.
please go ahead.
Okay. Thank you. Before I start, I would like to thank you all once again for being here today. It really means a lot. And by this occasion, I'm going to present our most recent study. The official title of the study is Children and Adults Rely on Different Heuristics for Duration Estimation. And probably we mentioned earlier, but it has been published in Scientific Reports Journal in January this year. After my presentation, Professor Nadasdy will take over, and also, of course, I will be here. So I'm sure we will be glad to answer many of your questions. But on the other hand, we are completely aware that this 1 hour long presentation probably will not be sufficient to cover many of your questions or many interesting topics related to time perception. So we would be more than happy if we could continue this discussion, and anyone is absolutely invited and more than welcome to ignite any conversation. Both of us are available on social media, so please just feel free to drop us a message and share with us what excites you the most. Okay, I think we can start. I'm not sure how many of you are familiar with the topic of time and what are your backgrounds education wise. So, here on the first slide that you all can hopefully see, I'm just going to start with a very, very brief introduction. A great question to begin with would be what is time actually? Well, the elaborate definition of time would largely differ whether it would be provided by a physicist, humanist, neuroscientist, or psychologist, for example. But a common kind of a meeting point would be that time is a fundamental concept and dimension humans are using to organize their lives. Despite for being one of the central aspects of human experience, concept of time is highly problematic both in physics and cognition, but nevertheless it is still one of those fields that attract a lot of scientific attention. From the developmental point, scientists are curious how do children reason about the temporal dimension before they adopt the metaphorical representation of time and before they develop actually supporting linguistic capacities. Generally speaking, how does the conceptualization of time actualize before the concept of absolute time is learned? Or, in a very simple words, how children utilize time without knowing to read so called mechanical clock time. Of course, in search of answers to those questions, we could travel far away and pay a visit to some of many isolated tribes of non-Western culture, where concept of a clock time means absolutely nothing. But also, we can also gain very valuable insights just by tracking the developmental trajectories and observing young children. So now we jump to motivation for our present study. Actually, what were the reasons to start this project? Well, since time is neither being resolved by any sensory modality nor has an innate metric system to rely on, our underlying assumption was that subjects might rely on different heuristics as available proxies. Heuristics are actually mental shortcuts that facilitate problem solving and probability judgments, and most importantly, they enable quick decisions. And they were introduced in cognitive science by Kahneman and Tversky in the mid 70s. I believe everyone is familiar with this. But now, going back to our study, we wanted to investigate whether different age groups conceptualize temporal duration differently and whether we can use the shortcuts such as heuristics when it comes to time estimation. Intuitively, we assume that the reference frame of duration estimates might change with age and that children and adults would indeed rely on different heuristics model. Why? Well, first of all, because of the naturally occurring complex biological maturation and increasing cognitive capacities, and of course, the education. And probably lastly, the increasing adherence to the concept of absolute time. In addition, we were curious to find out when does a shift from event-centered to event-independent time occurs. Regarding the methodology of the study, we employed altogether 138 subjects. However, we divided them into three groups according to their age. So the first group was made of kids 4 to 5-year-old, the middle group was school-age children 9 to 10-year-old, and the last group was adults or people who were subjects who were above 18 at the time of the assessment. All of the groups, they went through exactly the same experimental procedure, meaning that the subjects watched the cartoons that lasted exactly 1 minute. And although they were just exactly the same in duration, one of the cartoons was eventful with lots of actions and exciting music in the background, while the other was eventless, monotonous, with lots of repetitive and therefore predictive content. They watched both cartoons only once, so the method of the study was aligned with the so-called retrospective paradigm of time perception. Of
If I
course,
can, if Sandra, sorry, if I can add
of
something
course.
to it.
Hmm.
uh, uh, for those of you are you're listening and you have the slides on the display, this is the fifth slide that illustrates the actual video.
Yes, it has methods as a title,
Yeah,
so it's easier
or
to track. Okay.
fourth and the fifth. Yeah.
Hmm. Of course, the order of the cartoons was randomized across the subjects, meaning that the half of the subjects started their screening with the cartoon type A, while the others started with the type B. And because our youngest group was only 4 to 5 years old, we imposed a very simple experimental instruction and asked the subjects to compare the cartoon that they have just watched and just to simply make a pick which one of them seemed to last longer, A or B. A similar procedure was also applied to arm spread, where we asked each participant to represent the duration of a cartoon by spreading both of their arms. And for those arm spreads, we measured the distance between the arms with a regular Taylor meter that everyone has at home, I believe. And as well, we noted down the orientation, whether it was horizontally or vertically directed. Now on the next slide, we are moving further. You can see the screenshots, and they are made from the Balthazar movie, a cartoon that we used in the study, originally made and produced by the film company called Zagreb Film Production. It's an old and famous Croatian company. And as previously said, one cartoon was action packed, exciting, with a rhythmically and melodically rich tune, while the other was exactly the same in duration but very different regarding the content. It was made of eventless sequences and simple background music. And that being said, in such a very simple yet contrasting experimental setting, the critical question was which cartoon seemed to last longer, eventful or uneventful? So, exciting or boring one? Now we are jumping to the results section, and we conducted a couple of statistical procedures, very simple, just as chi-square, and we obtained the following. On this slide, you can see the bar charts, and those results show strong bias in each age group. So more than 67% of pre-kindergarteners perceive the eventful cartoon as longer, while 75% of the adults felt the same about the uneventful cartoon. The middle group expressed a similar but more moderate bias than the adults, and that confirmed the age dependency of the conceptual change and placed the critical time window of a switch between the age of 4 and 10. On the next slide, you also can see the bar charts. However, these ones are for the arm spread orientation. And regarding the arm spread orientation and the distance that we measure with the Taylor meter, there was a trend of using a horizontal orientation, and that was increasing with age. So while pre-kindergarten age kids use 50 to 15% vertical and horizontal gestures, by school age, that ratio changed to 85% in favor of horizontal arm expressions. The following results led us to conclusion that when estimating the temporal duration, children might rely on the availability heuristics, or in a children narrative, how much they can talk about something. That means that if the first cartoon was packed with actions and they could talk a lot about it, 4 to 5-year-olds would feel such cartoon as longer. The uneventful cartoon, in contrast, had no episodes and no storyline, and it could practically have been summarized with just a single verb. So the kids estimated that cartoon as short. On the contrary, the adults might be using the so-called sampling heuristics and operate under the rule of how many times they could sample the flow of absolute time. In other words, and when we try to translate this experience to real life, everyday situations, when we are bored or when we are not sufficiently occupied, we are able to check the watch and think about where else we could be at that time. And all these distractions enable us to sample the flow of absolute time. Lastly, our results support the hypothesis that 4 to 5-year-old children use heuristics to estimate time, and they convert from availability heuristics to sampling heuristics between pre-kindergarten and school age. In our study, pre-kindergarteners estimated the duration of the eventful cartoon as longer. In contrast, the school-age children and adults claimed the same about the uneventful cartoon. This tendency to represent temporal duration with the horizontal arm spread was evident among all three groups. However, it was increasing with age. The school age group was found to take an intermediate position between the pre-kindergarten and adult groups, both in duration estimates and hand orientation, confirming that age dependency of the conceptual change and placing the critical time window of a switch between age of 4 and 10, and proposing that as the period when children learn the concept of absolute time. In a conclusion, it's essential to realize that those fundamental concepts like time and space are more complex than we can pin down by a type of neurons in the brain. And it's highly advisable to consider both biological and cognitive aspects in order to successfully wrangle such abstract concepts. At the very end of this presentation, I would like to thank you for your attention, and of course, we are looking forward to your comments and questions. The whole study, together with supplemental data, is easily available as it was published under the open access policy, but on the very last slide, together with our contact information, you can find a link leading you directly to the scientific reports journal page. So thank you very much.
Yeah, thank you so much for presenting this work and these really interesting results. So yeah, also congratulations on designing the experiment this way and seeing these differences or acknowledging these detailed differences in even how to how younger children express um, the time concept. I think that was really interesting too. And I feel that's really interesting about the narration part. Did you, or do you think in the future it will be interesting to reanalyze this in the terms of um, how good their schooling system is? Like, um, because the narration part has also a lot to do with if their
Mm-hmm.
education is fairly good. Like, does this ability play into this? And maybe with children with like autism spectrum disorders also maybe have a different time
Mm-hmm.
perception due to their ability?
Mhm. Well, I would say that this is not at all like education related, and it's more specifically tied to memory capacity. So, if we just compare those two age groups or those three age groups, of course, that memory capacities are increasing with age. So, we cannot expect from a child that is 4 or 5 year old to have the same capacity as someone who is fourth or fifth grade. So those are very crucial but developmental changes. So at that age, many things are happening. Of course, we have those very, let's say, regular developmental trajectories. But of course, at that time, it doesn't only come to maturation and of those pathways. Also, the cognitive abilities they are increasing, and also the linguistic capacities, because such small children, they are lacking the vocabulary actually to describe whether something happened earlier or 2 days ago or 2 weeks ago or in February and so on. So those, I think it's a matter of developmental change. And the main thing is that we operate with the capacities that we are having. So that's why we propose that that children, that such a young children will operate on this availability heuristics, because it only requires the memory. So whatever they can retrieve, or firstly whatever they can perceive, and later on what they can retrieve, it will be available for them to narrate, right? So if they increase the memory capacity, they will be able to narrate more. But of course, it's completely different if we speak of older people or adults, because we don't rely so much on those memory capacities, although we have them already developed. But we use some another principle. Let's say let's like this sampling heuristics, because whenever we are bored, we are somewhere else in the mind thinking what else we could do or how many time already passed, and we are thinking in terms of this mechanical clock time. And children, of course, because they are not used, they don't know how to read this clock time, they are not using this at all. So it's a fundamental difference. And I think it's at one side it's very simple, however, it's very logical, and I kind of um, I
Yeah,
think it's a good, yeah.
yeah, it's interesting, but there are huge differences in how many words kids have available in this age, depending on if their
Mm-hmm.
parents read with them or if they spend more or less time on screens.
Mm-hmm.
There are huge differences, especially at that age when they kind of start getting into the public educational system. Then it
Yeah.
maybe adapts, like it becomes more generalized, like what words they have available. I was just
Uh-huh.
thinking that maybe a kid that has 1,000 words available versus a kid that has only 100 at, let's say,
Mm-hmm.
age 4, that
Of
maybe,
course, it
yeah,
totally makes sense, and we didn't go in that direction. But as we said, this is just the first step, and the study can go in many directions. I mean, we can employ different groups. So also we can take older people, because we took for our third group, it was mostly consisted of students. So for sure, it's not the same when you compare a student, someone who is in his early 20s, when you compare to someone who is 70 or 80. So I think it will be interesting to see with the time how this theory will develop, because I believe not just us, but many other probably research groups will be able to test how it goes and test many groups, so either younger, either older, or people having some developmental disorders and so on. So
Yeah,
I'm really curious.
yeah, I think
It,
it's really interesting because it would be maybe a fairly easy way to diagnose people with different disorders. I don't know if you know about this
Mhm.
Parkinson test where
Of course.
people
Hmm.
with Parkinson are supposed to describe a picture where there's a lot of motion happening, something
Uh-huh.
falls and the person has to move. And people with Parkinson really early on, even if they don't have this highly severe um, uh,
Yeah, if it's not
physiology, yeah,
stage 5 or so. Uh-huh.
the description of the picture has fewer motion words, which is really interesting. And that's why I was thinking that the language
Hmm.
available and the description can tell us a lot about, developmental maybe or
Hmm. Hmm.
different type of disorders. And when you say when it switches due to education of using a watch or
Uh-huh.
something like that,
Or
that would
writing.
also be,
Hmm.
yeah, that would also
Hmm.
be interesting if there's kind of maybe in some people with different disorders, if there's kind of an in between that they kind of use both or not so much just this, if the abstraction maybe of time, maybe it can hint to also other neurological disorders if
Of
you cannot
course.
make the
Hmm.
abstraction as well. Anyway,
Hmm. Hmm.
thank you.
Of course, I just want to make clear one thing, because when we said, or when I said education, we didn't think of a formal education like going to high school or attending a university degree. We thought just like being exposed to writing and reading, because that influence a lot our direction, like how do you sort, how do you order the things if you are just if you are just using a very simple line. So all of us who are in this, let's say, western part, we are used to write and read from left to right. But people in Middle East, they do it like in reverse fashion. So it's influencing actually how do we conceptualize things also in our cognition. So I just wanted to make that part very clear. So this orthography, or the direction of writing and reading, is very important, and that's why we asked kids to represent the duration by the arm spreads. We were curious to see whether they would direct their arms horizontally or vertically. And also, we kind of thought that at the very beginning, if they align, if they put their hands horizontally, they would think of time as something like length, and if they place their hands vertically, they would think of time as a quantity. So that's why we wanted to see whether such simple thing like a simple hand gesture can pinpoint something deeper, like something that is embedded in our recognition. But yes, I agree what you said about Parkinson, and I think, of course, it cannot be used as a test, but action, what you said, it's being questioned in this test meant for Parkinson's people with the diagnosis of Parkinson's disease, is actually at the time is always closely tied to action. So whenever you think of something like what were you doing yesterday, you always have in your memory embedded like space, time, and action, right? So yesterday at 9 a.m., what I was doing, I was answering my email. So you always have time, space, and action. So as you said, among people who are diagnosed with the Parkinson's disease, this third part is kind of a lacking, but everything is interconnected. We cannot put aside like one aspect and then speak about time separately and then speak about space separately and so on. So everything is really important, and of course even harder it is to disentangle those things in terms of neurobiological, because dopamine, that is very important for actions, and Parkinson's disease also plays a role in timing. So I think it's very interesting overall, and it's never boring area.
Yeah, it's
can I?
very interesting. Oh, yeah, please go ahead. Yeah.
Sorry, can I add something? Yeah. Going back to Katrina's question, she brought up autism, which struck my attention because it's actually really relevant point that there's some dramatic change happens between age of 4, 5, and 6, 7 with basically the school, and this is our perspective with respect of time. It just completely changes, and this is consistent with that, with going from egocentric reference frames to allocentric reference frames in spatial cognition, and also this coincides with the age of the theory of mind, or false belief or mentalization, when kids learn to think with somebody else's point of view, somebody else's mind, right? I don't know how many of you are familiar with the test of Sally and Anne, when the kids are asked a question that requires to answer from somebody else's point of view. So younger than 4 years, or the kids usually fail on this test. And also, interestingly, autistics fail on this test. Now, what we see here in in our experiments is actually exactly the same thing, that our perspective with respect of time is changing. Kids think about time from an egocentric point of view, how much they can talk about it. It's a performance, how many sentences I can make, how long can I how many episodes I can recall. And now when you are asking an adult, he or she will be she will be referencing time as an absolute entity, that we are all part of it. So the reference is now outside of our life. We are all basically, if I can find a good metaphor how we think about time as adults, is that time is absolute. It's like a flow. It's like a river that has a very rapid flow, and what we are sitting inside a boat, and that boat is traveling with the stream. But we don't experience time if we are just looking at each other and having conversations, and there's no evidence that time is passing. You need to go to the outside and look at the riverside, and when you see the riverside moving, that's an indication that the boat is moving. Uh, so so sampling the absolute time is equivalent with changing the reference to what we call in spatial cognition allocentric reference frame. You are centering the events to the environment, not to yourself. You're stepping outside of your body. So in that sense, it does relate to that, what you mentioned, Katrina, the autism. And I'm not proposing that this could be a test, but basically anything could be a test. And this is a very simple question, a very simple test that he could serve some kind of prognostic tool in the future. I don't know, but it's not a bad idea. Thank you so much for asking.
Oh yeah, thank you. Yeah, I was also thinking of dyslexia and so on. Which are all kind of on the spectrum. I don't know how big the differences would be, that you would be maybe
Yeah,
reliably, but it's a challenge because we know that if we get kids early on into educational programs that are kind of adapted to kids with these kind of different ways of learning, they can do really well in the future, and the beginning of schooling is so important for the future outcome in self-esteem. And even another, we had like rooms about that with other guest speakers for the whole future of achievement. So if this would be kind of a relatively cheap broad scale test that we could assess and then give children the opportunity to to learn in their way, that would be amazing. But yeah,
Yeah,
would be
yeah, I
interesting.
agree. And we have not really exploited this to, as you mentioned, you can dyslexia, autism, attention deficit disorder. So there's so many that we can look at how sensitive this test is for all these disorders, and how can we intervene in time when we recognize these problems. But there's definitely putting together a narrative which this task requires would be, yeah, a very, very powerful test for, that is depends on the vocabulary of the kids, the memory that Sandra mentioned, cognitive ability to organize things in time dimension until time becomes its own separate dimension. That's what we learn in school, and one of the really fundamental concept that we learn in school is simultaneity. So that takes us to the allocentric concept of time, is that you able to learn, you're able to conceive that while you are sitting in math class, your sister may be sitting in another class, let's say music class, and you are on the same schedule and the same time. And when you finish your class, your sister will finish exactly the same time. So this concept that we are all living our life simultaneously, and when then we 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 merge, or we intersect with our life trajectories, then depart again. This is the way we adults think of life, and it's really transforming our view on things. So then, there's a vast literature in, and I'm thinking of like novels and movies about the how our life trajectories intertwine, intersect, depart. This is a wonderful things that is really making our life complex and fulfilling.
Okay, I just wanted to add a simple line, because when we discussed about opportunity, or actually opportunity of using the duration estimation task as a diagnostic test, then I believe we should also code for the order, not just for the duration. So it wouldn't be just dependent on the memory capacity, but also on the order, because time, it has two features. So it's duration and it's order, and I believe this second feature, that is order, would be more relevant for dyslexic kids or something like that. So I believe, it's definitely has some potential, but we didn't think of going in that direction.
Well, thank you so much. And I wanted, if you still have time, please let me know when it's like the last few minutes you have to leave. So, because a few people joined the stage. So just let me know when I should stop taking questions. And yeah,
Okay.
Akil, do you want to? Thank you.
I'm available still.
Yeah, well, thank you so much for presenting. It was really amazing. I enjoyed it. So I have like few questions. So the first question is, like, in your study, you guys presented participants with a 1 minute eventful and uneventful video, to assess
Mm-hmm.
their perception of time. So I'm intrigued by the possibility of manipulating other variables within the videos, such as the, let's say, speed, at which the events unfold, or maybe the complexity of the events themselves. So how do you think varying these factors might affect the way children's or adults perceive time? Would these changes in the video characteristics have a significant impact on the heuristics that you mentioned employed by different age groups for the duration estimation?
Uh, well, I can take this. We did. I first of all, Akil, completely agree with you that these tasks are very complex, and there's a lot of features that you can vary. Uh, One thing that Sandra also mentioned was that we had a music undertone during these cartoons, and we were we were also wondering how much the music, the rhythm, the pace of the music, the melody itself might have contributed to the result. What if we take the music off and somebody just watch this movie silently? And Sandra actually did this control without music and without any sound, and it turns out that the result is exactly the same. So music itself did not really influence it, but other elements that you mentioned, such as the number of transitions, color changes, uh, transients, moving characters, the number of characters introduced, the episode boundaries, these are all probably factor in when we compare these movies. At certain point, of course, if you balance everything, then you are basically watching two identical movies. But there is a large room for these type of features to affect time perception. I don't know if Sandra would like to add something to it.
No, I completely agree. And we were also kind of worried because of this, but then kind of assured after we did this control study. And as professor said, the results were completely the same. So I believe in maybe in some of the future ventures we can try to modify, but of course that's one of the most important probably methodological thing that everyone who will be conducting this or similar experiment should pay attention to.
Great, thank you so much. Do you guys have another time for another question?
Oh yeah, absolutely.
Yeah, we are here.
Okay, so your research also delves into the intricacies of observer independent absolute time, from a cognitive
Mm-hmm.
science perspective. So, which is undoubtedly a crucial aspect of understanding human perception of time. So, my curiosity however, extends to the potential influence of cultural factors. I think you guys discussed a bit about that. So,
Uh-huh.
cultural factors on the assimilation of absolute time and the heuristics employed by individuals in estimating durations. Like specifically, I'm more intrigued by the existence of any cross-cultural variations in the temporal perception and the implication of these variations on the development and internalization of the concept of absolute time.
Mm-hmm.
I think Sandra can take this because she knows a lot about this.
Yeah, I can take this one. Well, of course, if we think how large is the planet Earth, of course there are people who are living in culture that doesn't align with ours. Right. So we could, of course, travel or actually get in touch with other researchers who are in charge for those isolated tribes. But however, there is already a lot of literature available online, and maybe if you are familiar with the work of Lera Boroditsky, she did something in terms of linguistic differences. However, what is relevant here for us is that those guys they do not rely on this so-called clock, mechanical clock or watch time, right? So they navigate or they use time in a sense that they rely on the events. So basically, they are using the same principle, the same law that kids are using in the Western world before getting aligned with this so-called mechanical clock time. Of course, I don't want to. I'm not using this to underestimate their knowledge to navigate and to having of a sense of time, but that's how the things are. And actually, they don't need a watch, and they have everything, let's say, centered or event based. So if they want to meet in a distance or if they want to meet in 10 minutes, they say, okay, we can meet when the rice boils or something like that. And once I read, and that was super interesting because I think it was related to the Aboriginal tribe. And those guys are super interesting because they even use they are interesting because of those directions, and they align to those cardinal dimensions. So they never say, for instance, okay, you are on my right side. They always say, okay, you are standing north of me, or something like that. So I think it's very important to be familiar with, or actually to know how other people are conceptualizing the time, and the fact that time is not universal. So it's really relevant for us to know that how such fundamental concept, and something that is truly human experience, right? Every one of us, we need time, and we think in terms of those temporal axioms. However, it seems that it's not a universal thing. So I agree with you. It's really exciting, but so far I didn't find many papers related to this area. Only this Lera Boroditsky work.
Yeah, I'm aware of that. You're talking about like linear versus the circular time perception, right? Like with the
Yes, exactly.
yeah. Okay, cool. Well, thank you so much for answering. I do have some questions, but I would like to pass on the mic, and if there is extra time at the end left, I can ask that. So I would pass on the mic to the next speaker. Thank you so much, guys.
And of course, we left our contact information on the last slide, so please feel
Yeah,
free.
yeah. I
We are
already
on social
sent
media,
like
so just send us an email. Mhm.
yeah, I sent like LinkedIn
Sure.
requests to both of you already.
Okay, no problem.
I have a question. Can everybody hear me all right here?
Yes.
Yeah,
Yes.
let me just
Hi.
ask Nestle if she wanted to ask
Oh,
something
I
because she
apologize.
was waiting. Yeah, yeah. Nestle, did you want to ask something?
Hello, yes. I wanted to ask, hello everyone, thank you so much for this amazing session. I wanted to ask about the standard deviation for the result of adult estimation. And does it imply something in your opinion if like my estimation be more like, for example, similar to the children, or what does it say about that brain? Or and the other question is do you know if the people in the experiment watched the cartoon as an outsider, and it could be that the experiment could be different if you would ask the question when they were solving a mathematical, for example, a scientific question that requires their direct involvement and their the activities of their frontal lobe. I'm done. Thank you.
Oh, I can take that. Yeah. So the first question about the standard deviation. Thank you for asking. Yeah, it's we did an extra statistical test on comparing the variance of responses between the kids and adults, because we thought about it that maybe what makes also different makes a difference between kids and adults is that the adults has more consistent responses, and that's why we compare the variance in the responses. And but we found that there is actually no difference. So we were comparing our arm spreads variations, and there's really that didn't explain any difference. Uh, there's no reduction of variation with age that we could anticipate, just based on that all the skills what that adults learn are kind of improving the precision, like time estimation is also improves with age. We did not notice any such difference in our data. Now back to the second question. Uh, when you were, what was it? Sorry, I'm phasing out. What was the second question?
If the
Oh, on
people
the
experiment were all seeing it as an the videos as an outsider, and they could be different
Got
if
it.
they were
Yeah,
actively involving in
sorry.
things.
Yeah, I mean, yes, what we are doing now in one of my students is looking at virtual reality that makes the experience more immersive. You are basically inside of the story, inside. You're part of the scene that is happening around you, versus you are kind of outside of the story. You are just an observer. You are just looking it through a camera. uh, so we are comparing these scenarios, and we are looking at how the time is experienced, and experienced, whether it's experienced differently. If you are involved, you can turn around. You get a 360-degree view on the scene. Let's say a prison break or bank robbery. Versus we are also having very boring, just eventless, you, let's say you are on a beach and just looking around and enjoy the surrounding, the nature. uh, so so I cannot answer to your question whether this makes a difference, because it's a work in progress, but we are absolutely uh, tackling that question. Whether it's it's frontal lobe, or what brain areas might contribute to it, would be the next question in line, and that we could take it to a MRI scanner and looking at the localization of contributing brain areas would be something down on the road. Absolutely, it's on our roadmap, but I cannot really speculate more on that. Does that answer?
Thank you. Yes, thank you.
Perfect. Thank you. Kyle, do you want to go ahead now?
Yeah, absolutely. As I was formulating my question, I sort of simplified it to a question of, are you guys aware of any potential for perceived impermanence that may relate to, like if in an example, I'm not sure if you guys did this, but if in these two different scenarios, like the heart rate was being monitored,
Mm-hmm.
and there were different types of sympathetic resonance occurring between both scenarios, because it's still an objective stimulus. How might the differences between sympathetic resonance in these scenarios potentially affect a perceived impermanence that could be related to objective time?
Yeah, um, I can take that. So there's of course there's a number of biological clock-like mechanisms in our brain or in our physiology. And you mentioned heartbeat. There are studies that shows that we are actually have a time dilation effect that correlates with heartbeat. Now, also, the brain has a number of structures that have kind of regular pacing rhythms that kind of provide an internal clock that we could theoretically utilize when we estimate time. Now, I like to think about all these physiological clocks as really a potential uh, time ticking mechanism. However, it doesn't really answers the question of who is reading those clocks. So just to have clocks in our body, uh, uh, it it only contributes to the answer if we can propose that where is that homunculus, where's that little observer inside our brain who would read and compare those clocks. So I think time is more complex. That's something that you could reduce to these impermanences, or something that just something internal, that's something our internal organs or our brain generates, because it requires a framework of some conceptual framework of how do you how do you uh, a conceptual model of how do you think about it. And that's exactly what we try to pinpoint with the heuristics. It's the heuristic is something, as Sandra explained, that something doesn't exactly measure what we need, but it's good enough to give us an approximate answer. And because we don't have any sensory organs to specialize reading time or comparing durations or counting, therefore we must rely on these other proxies or heuristics. And so from my point of view, it doesn't really matter if we have those clocks inside our body or outside. You still need a model, you still need a heuristics to make sense of it, and compare it, measure it, compare the memory of it, count it, and reference it, relate to it. I don't know if I'm answering your question or not, but please feel free to correct me.
I hear what you're saying, and it's interesting. I think I'm really a little bit just curious and surprised, I would say, I guess, by the result that a more repetitive action, perceiving a more repetitive action might follow up with a perceived shorter amount of time. And it feels to me like it's like intrusive on the perceived impermanence of a person based on those biometric clocks. Because if there's like a standing wave of a person's, overall brain state that's sort of rooted in their fear-based evolution, then it sounds more. It actually surprisingly seems like repetitive actions are more intrusive on it may induce more of a state of stress that's maybe shortening telomere length or something like this. That is interesting. So
Yeah. There are actually a number of studies that relates to time dilation and compression under stress and anxiety, which is obviously, emotional states are completely affecting these time estimates, and those are contributing factors. I don't deny that, but and I wanted to add that when we all have the experience, when you are sitting on a boring meeting, that time expands. It just feels like, as this is dragging on, when is it gonna end? And when you are sitting on this boring meetings, you might be monitoring your internal state more closely than if you are engaged to something, a joyful events, like you are playing a sport. So when you are just bored or not occupied enough, you are monitoring your internal state, and those internal state monitoring, like counting your breathing or breathing rhythm or heart rate, you feel it. Those may add up and contribute to expanding the perceived time duration for those activities, in contrast with something enjoyable. And maybe that makes sense if you think about it.
Can I also make a short reply to Kyle?
Please, yeah.
Yeah. Okay, so I just
Oh,
wanted to add
thank you.
that having a repetitive actions actually doesn't require that much of cognitive effort. That's why we perceive them as shorter. So nothing is happening, or although it's happening, but nothing is new. So there is no change in that sense. So that's why we are kind of just utilizing and being very economical in terms of what we are going to process in our cognition. But also, I wanted to add that, of course, I agree with Professor Nadasdy. Both biological and cognitive models should be employed in order to explain time, and nothing should be reduced only to biological models. However, Kyle, if you are interested and if you are going in this direction, I can recommend for you to look for set theory, probably, or maybe you are already familiar with it. It's abbreviation for scalar expectancy theory, and it was proposed by Gibbon in 70s. I don't know exactly the year, but it's one of the information processing models, and it's one of the most important models of animal timing behavior. So they propose the existence of this internal clock, meaning that the number of accumulated pulses represents the elapsed duration. So it's very, very different from this cognitive based theories. And also, on the other hand, you have time cells that are, I would say, very popular lately because they were considered as a counterpart of the space cells. And we all know that that discovery led to the Nobel. So people or researcher, they try to be very fast to pinpoint like what type of a neuron in the brain keeps track of a time. However, there are many works, and I can recommend his name is Tsao. He is a guy who works at, or he worked at the Kavli Institute in Norway, and he is very into this topic of time cells. So, and also the reference for the heartbeat, I know there is a paper that has been published maybe like 2 or 3 weeks ago, because I met that girl recently when I was in conference in Berlin, and it was published, or it was written by her name is Irena Arslanova, and her supervisor is Manos Tsakidis. So if you are interested in this direction, they talk about time perception and heartbeat. So just a few recommendations if you wanna continue your reading.
Thanks so much.
Excellent.
Yeah, I appreciate it.
Of course, you're welcome.
Yeah, thank you so much for all the questions. And I don't know, Akil, did you have the last
Yeah,
question
I had
before
one
we close?
question. If they are free, if they have time, if they don't have time, I won't.
The time is all we have.
And time is relative.
Yeah.
Should I ask?
But yes, go
Yes,
ahead. Of
yes.
course,
Okay,
of course.
so firstly, like I'd like to acknowledge that this question like may extend beyond the scope of your current research, and I understand the differences in time perception between children and adults are, likely more related to cognitive and developmental factors. However, I'm intrigued by the potential relationship between the concept of size and our perception of time across varying sizes or objects. To offer some context and an interesting perspective, let's ponder the scenario of the fictional character, like Ant-Man, who possesses the ability to shrink or grow in size. So when he's smaller, events might appear to unfold like more slowly due to the physical constraints of his size. So in the context of your research, could this concept of relative size have any implications for how children and adults perceive time differently? For example, might the physical differences in the size between a child and an adult observer contribute to the variation in the time perception and the heuristics employed for the duration estimation? Additionally, could this idea be extended to the perception of time by different objects or non-human entities, given their relative size and physical properties, that might influence their experience of time? Thank you.
Hmm.
Okay, thank you so much. Yeah, this is a really interesting question, and I never thought about this. There's an obvious relationship between the size of the brain and lifetime and the time of let's say perception speed. So the larger the brain, the longer does it take to travel information, from one part to the other. And there's also a very apparent correlation between animal sizes like elephants, whales that live proportionally longer than smaller animals. If you watch birds or insects, they seem like they respond to the interaction with the environment is happening on a much faster time scale than our interactions. So that raises the point that maybe the nervous system is working on a higher clock speed than our nervous system. Then it all makes sense that they live a short life, but maybe they fill up that short life with much more events that they perceive than us. So this is just raising so many interesting questions, but specifically how the kids size, uh, I mean, they are being smaller than adults would change the perspective to time. My first intuition would say it doesn't, but I have to think more about this because um, yeah, I can't really rule out any or all the potential confounding factors that derive from the size difference. It's absurd. It's an intriguing question. I don't know, Sandra, you have something to add to it.
I think this is a perfect space and time to say that live slow and die old.
Yeah.
So it's not trend anymore to live fast and die young. So yeah, I think it's interesting because whenever you think of elephants or turtles, they are very slow, but they can live up to, I don't know, 100 years or even older.
Yeah.
So yeah, it's very interesting. But yeah, if we go back to your question, I don't know, to be honest, how object size and time perception are related. However, there is a theory by Walsh. It's called theory of magnitude, and actually it's proposing that there is a common magnitude, like center in the brain, that that it's being used for all the magnitudes, for all progressing processing magnitude. So it doesn't matter whether you are thinking of a length or a duration or something like that. So it's very useful when you think about if there is a something like that in early developmental stages, because for instance, the kids, they firstly learn like if something is small and big. So that's the first discrimination, and of course everything envelopes or develops beyond that, and it goes more complex and more complex. However, this theory is also very interesting because it's very useful and again very economic.
Yeah, like
There's
Zoltan
one.
pointed out about like big brains, right? Like so, like in
Yeah.
larger animals, like the transmission of information across,
Yeah.
across longer distances within the nervous system might take more time.
Uh-huh.
Yeah.
But remember that the time, the speed of light is constant. So, like you mentioned, I think I heard something about time dilation. Do you think that can play a role in this? How like small organisms like tend to live
Yeah.
fast and die young, kind of thing.
Yeah. Yeah. Live fast, die fast. Uh, um, Yeah, it's a really conflicting question because in one hand, just every behavioral observation suggests that they are responding faster. Take a example of a fly or a cricket. That they respond to any changes of the environments much faster than human reaction time. On the other hand, the nervous system consists of neurons with the same conductivity, same conductance and speed of synaptic delays as ours. So they have the same gamma oscillations in their brain. So their brain rhythms are the same, even though they don't even have brains, they have ganglions, right?
Mhm.
So it's really a very intriguing contradiction that I cannot resolve right now. But when you, I was thinking, uh, what you said about the size, that from a kid's perspective, living in an adult world, and this how as they grow up, the size relationship changes. All of us probably have the same experience, and we go back to our school where we, like elementary school, to go back to the building. When you revisit those locations, everything feels so small, right? And so so obviously, when you are a small kid and your step size is half of the step size of your adult step size, it takes twice as long to walk through that building or you went to school. So the distances are larger, the space is larger, everything took longer that time when, as an adult, going back. I wonder myself if that makes any difference or distortions of time. So I'm thinking of an experiment where you can just go through a hallway as a kid versus an adult, and it could be a virtual reality experiment. You are going through the same hallway, but you have different sizes, different eye height. Would you experience time differently from a lower eye height point of view? That's a kind of interesting question to me right now. I don't know. I can only speculate on it, but it's a good idea. Great idea. Thank you.
Yeah, I wanted to add another factor that I think that might play a role. We had the guest speaker here last week that showed different, because there's all this literature claiming that children learn at a faster pace than adults, so they can absorb like more information and retain it and learn at a faster pace. But nobody actually studied how that might be, and that's an actual true fact. So what he found was that there's the big difference between an adult brain and kid's brain is the inhibitory GABA system. It only is fully finished pretty late on, with 25 years old or so, more or less. And he found differences there, although it's not fully developed yet. When a child learns afterwards, the GABAergic response basically is much higher. So GABA levels in the brain, where kids then learned, like the brain regions they looked at, the release was much higher in children than in adults. And he could show that kids can learn at a pace of an interval of 10 minutes. Adults need around 2 hours until they can really retain the next knowledge and not erasing basically or overriding the previous learned knowledge. And he found that that has to do with the GABAergic system. So I would assume that maybe something similar plays a role in time perception due to higher GABA release after a signal comes in, that you basically stop the signal to make space for the next one at a faster and more efficient pace than in the adult. So maybe the time perception is also dependent on that.
Yeah, thanks so much. It's a very complex question uh, because one hand, GABA is very directly linked to gamma oscillations in the brain. That's the inhibitory circuitry in the brain. So it relates to brain rhythms, but we don't really see difference in terms of the frequency of brain rhythms between kids and adults. But we do see the prevalence of those oscillations and the duration of those oscillations relative to other oscillations in the brain. But in terms of inhibition, uh, that 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 takes. You mentioned that the maturation of those inhibitory pathways takes us to far later than adolescent age when they finish and they complete. It's true, and that could potentially contribute to to changing of time perspective. Uh, I I haven't considered this angle, but totally um, uh, feasible that, or I can think about. It's conceivable that that these inhibitory mechanisms uh, may uh, play an important. What I've been thinking also is that, you know, for adults to learn something that what may make it more time consuming to learn, let's say, a new skill relative to a kid, is that we have a lot of interferences because we are already in possession of so many skills. So to learn the new skills, you basically need to work other skills, suppress other reflexes and skills to make room for a new skill. And why children, they don't have those larger repertoire of skills yet. So it's easier to learn something new, easier to allocate neuronal space in the brain to something that they have not, that has not been occupied by another skill. So all this just makes the question so complex that I really can't shortcut here to give you a quick, convincing answer. But it's a really good proposal.
Thank you. And Peter, he's a, you know, he comes from the athlete, high performing world. If you still have time, he wanted to add something to the discussion. Thank you.
Yeah, I think this is, I would listen through the thing, the presentation from the beginning, but what you talked about heartbeats and so forth, I think that that has a parallel in certain ways, and also the perception of time for both kids and adults and so forth. And the thing with, if you take my resting heart rate, the lowest measured has been 29, which is fairly low.
Wow.
Oh, wow.
Yeah,
So
So
uh,
long.
on the other hand, and I have had
that's like
friends,
hibernation.
yeah, let's put it this way. The thing there, where that has a relevance for the how the brain and time is, when that means that the explanation for the heartbeat there is that that is not uncommon to have that level or that heart rate for international level
Atlas.
endurance
Mhm,
athletes.
mhm.
And the problem is if you go to a hospital and a normal doctor checks you, they wonder if you're about to die soon and you're in
Right.
serious trouble and they will keep you overnight at the very least. So, but the thing there is that the heart then can pump way more oxygen and blood around, and at, and that means that you can have a much higher performance. So you have fewer cycles and so forth, and it probably affects, unless it's a heart problem, it affects longevity to a certain extent too, because there has been theories about that many animals, including humans, have a certain number of heartbeats, roughly, if you generalize. And the lower resting heart rate you have, or the lower heart rate you have, the less you strain the heart, and the number of heartbeats last longer, so to speak. However true that is, but if you look at a number of animals that have high heart rates, heart rates and so forth, so where this links into to the brain and so forth with athletes, the people that know what they are doing, they need to run through very few cycles to analyze the situation and to see what they need to do. And if you were to correlate time perception to the number of cycles in order to figure out what is going on around you, if you do not understand that what is going on around you, you will be anxious, stressed, and the brain will run through many cycles to try to figure out what is going on, which will probably give a time perception that time moves very fast. So in high level athletics and in many other, and it maps over very well to lots of other areas where if you understand or have the capability of figuring out what is going on, and even in situations where it may be threat to life, but you know what you need to do, you may not like the situation, but you may be calm and focused and get on with it. If you make it out of there alive or not, that might be touch and go anyway, but your odds are very different. So I think that um, I don't want to say anything more if you think that I'm not on a track that
No,
maps in any way that is relevant for what research you have done. And so otherwise, I'm very interested in discussing more about it, maybe at some other point and so forth. But so anyway, um, those were my thoughts. I hope it made sense.
yeah, totally. I mean, you brought up a couple of points that are really interesting, and one is that from, let's say, high performing athletes, I can think of certain type of performances like, for example, pole jumpers, and when they have to focus on right before they performance, they kind of anticipate the sequence of events. It's kind of predicting what's going to happen, and when they are on that on high on the pole, that they describe it that those few seconds, or it doesn't even last few seconds, it's just 1 second, the time dilates, the time expands. They kind of sample that time interval with much more samples, much more details, uh, and so they are present in that 1 second, which is the critical moment of whether they are passing the bar or not. So this kind of focus on certain sport or athletic performances can make time dilate is absolutely conceivable to me, and it would be really interesting to look at that with, I don't know how, probably looking at memories, or replaying the events, replaying it from a first person point of view as what they saw, replaying it from a third person point of view, like the camera man from the side. How does it influence? uh, yeah, I just don't know. I mean, people did experiments like, people went up to a tower, did bungee jumping, and they measured time while jumping, and do time estimates, and nothing really interesting came out from all those researches. So I don't really know, but I feel like there is something there. So that's a
I
good
may
point.
have some ideas about that if you, but we
Okay.
can discuss. The other thing that I want to add is that the thing about if it is not like pole vaulting where it's one individual jumping by himself,
Hmm.
if you have competitive situations where you're competing against one other individual or a team, one of the things that I've always told people, rule number one is make sure to unbalance your opponent, because no matter how skillful they are, if they are worried about things, all their capabilities goes out the window, and it doesn't matter how good they are under optimal. No, you're laughing, but
Okay.
you're probably
Yeah,
laughing
no,
because you.
The
it's the psychological warfare that is part of it. It just reminds me for, chess players, how they distract each other
yeah,
from, from the checkerboard.
I remember Daniel Kahneman's book right now, how he also helped the Israeli military, but also professional sports to pre-select basically who will, to find the next talent and who will do well, and to try to figure out, and that this was, one of the hardest problems and probably still is. So, Peter, do you think that this ability to slow down it's kind of a ODA loop, right? From the military perspective, do you think that this is an intrinsic ability people have already before? Because if yes,
No,
no, yeah,
no,
but
it's
could
not.
it be like that you have already a good memory retention to
No, no, no,
begin
it
with?
hasn't. No,
I don't
that's not what is the critical factor. The thing with it is, and by the way, you don't need to the psychological warfare, so to speak. It does not have to be in a nasty way or evil whatsoever. It can just be a strategy that the opponents have not seen before that makes them confused. And going to the OODA loop is perfectly good idea. The problem with the understanding of the OODA loop is that it's so poorly understood, and I could map that out in a much better way because John Boyd, that developed the idea, he explained it so, but the people that have read it, that have looked at it afterwards, understood it so even worse. But it can be explained much simpler. The thing is the understanding, and you can train people in that very effectively. The people, what seems like natural ability, are people that got a way of learning and figuring things out at a young age, and then that snowballed over time, and how to do that in various environments. But most often, people have it in one area because considering there is no one training in it, I've been playing around with how to train people in this, and it can be done now. I wasn't sure a couple of years ago that it could be done. However, the thing is that most of the time people learn how to do it within one area of life, but they don't understand how it generalizes over to other areas, and there then can start to use it in just about anything and everything in their lives because they came across it by chance very often or were coached
Yeah,
anyway.
I
Yeah,
was
sorry, Sultan.
yeah, I was thinking, to find the next big soccer player or basketball player, you need to have this oversight that you mentioned in the beginning to quickly assess a situation without going through a lot of loops. So I was thinking, if in children, it would be interesting to see, it would be a long-term study. But let's say you screen in children before they switch to this clock time perception learning, the test for 4 to 5 year olds and so on. If the difference between those two videos is bigger because they retain more detailed information about actions that are going on in the more interesting video, if that would be a good predictor, if they become athletes later on, that they will do better at sports like, fast-paced group sports like basketball. And then later on, you wouldn't be able to use that test anymore very well because you were trained differently. What time is meant? I would just be interested in seeing that.
Wow, yeah, um, that's again, well, we did not really think all this.
No.
I mean, you bring so many angles in it. Yeah, if we could use this as a predictor of any later sport performance, I really don't know. There's it could be a good predictor, actually. A number of things like musical abilities, uh, any kind of memory involving performance later. Um, yeah, I don't know. You brought up sports. It could be a, but I wouldn't rely on selecting kids, for different sports based on this as yeah. But I can see the perspective. Yeah, it's something. It could be part of a much more complex task that could select, future high performing uh, sportsmen. And yeah, I don't know, Sandra, if you have anything to add.
I think this time I don't have anything to add. Like the sport was the very last thing on my mind when writing this. So yeah, I agree that whatever is memory capacity is related, then probably the cultural effect or cultural inclination, it would be relevant. But as you said, maybe it could be part of the battery, so not just one single test, because it's I think this general attitude of reducing many complex things just to reduce on a single test or a single approach is never a good one. So always it's better to imply multidimensional approach. But sport, I never thought. I'm sorry.
But it
I'll
makes
try.
sense. It totally
Yeah, yeah,
makes sense because sports
definitely,
is all
definitely it
about
makes.
timing and
Yeah,
precise timing and action and coordinating with others too.
uh-huh.
So
Yeah,
it's spot on. It's
of
something
course.
we can look at. Yeah, it's a good
Of
idea.
course, and for me it was really very intriguing when Peter mentioned this competition part, and when you are running or when you are racing, and then you are also monitoring yourself, but then you are taking, you are also looking for the others participants. So it's kind of, it reminded me on this egocentric and allocentric frame of reference. So it's interesting.
The legendary football player Johan Cruyff, he was known for being able to walk by some other world-class football players, and I knew that he had that reputation. And then I heard a quote for him where he said something in an interview that was absolutely brilliant, because he said most other players need a meter and a half within that circle around them. They can control the ball. I could wait until someone was between half a meter and a meter away from me before I needed to move,
Mm-hmm.
because he had such brilliant control. That also meant that he could see which foot they took forward, and also knew that that limited where they could move next, which meant that if they had planted the right foot, they could not easily move to the right. So he could go pretty much walk by them on the right side. If they had planted the left foot, he could go around them on that side. And they could do nothing apart from reach out with their arm and give him a free kick. So the thing was that the skill level and the brain to actually know that I wait and see their move. And it's the same thing with martial art masters. They wait to see the opponent make a move, and then they know all the things that the opponent cannot do and can take advantage of that, and so forth. So the skill level and the understanding what that means are tightly connected to each other, as far as I can see. And that also means that time slows down for them in a way, because if that makes sense. Anyway, I hope I
Yeah,
added something to the discussion.
yeah. Do you think that to test this in adults or like teenagers, to pre-screen, would it work maybe better to just have, let's say, 10-second clips? Would that kind of change them to like force people to use this internal type of time perception and not the clockwise one? Like if you shorten the time, that you go back to basically your childhood assessment type?
Yeah,
Mhm.
that's a really good question too. We only explore the minute range of time, but going down with a few seconds or expanding it to let's say more than 10 minutes, like movies, we have the same kind of movie. We have the same experience in movies, boring movies. The same hour and a half feels completely different from a very action-packed movie. So that's a completely different um, duration scale. So going down to a few seconds, it would be a really interesting question to look at if something is changing there from, let's say, a 4 or 5 years old kid's perspective, just because changing the time scale. I can't answer. I don't know.
I
All
would
these
say
are
that.
valid
Uh-huh.
questions, and it's
Mhm.
really crying for continuing these explorations, these experiments.
Mhm.
Well, thank you so much. I think we've been discussing 2 hours, so I didn't want to
Yeah.
overstretch your patience.
Yeah.
And this was such an interesting discussion. It was really amazing and really, above expectation, interesting. And thank you, Peter, for adding the athletes part. And I hope you enjoyed it too. That was worth the trouble, making the Clubhouse account and coming here. So I hope.
Absolutely.
Wonderful.
Of course.
Well,
Of course, it was
thank
a
you so
pleasure.
much. Yeah, thank you so much. It's a really great experience because this is the first time we are really opening this topic to the broad audience, and as you can tell, we get so many different angles that yeah, it's going to take time to integrate all these thoughts, and it will certainly shape the next few experiments to get all these feedbacks. So thank you very much. I really appreciate everybody's feedback.
Well, that's so wonderful to hear. And yeah, thank you everyone for coming and asking questions. And yeah, I hope maybe, once you have more more we can meet again. That would be really fantastic. So
Absolutely, I would be thrilled,
Okay.
and thank you so much. This seems like it was such a wonderful forum that you created here. So I would be happy to join.
wonderful. That's okay. Thank you
Okay.
everyone. Thank you,
Um,
Sandra. Yeah, go
Katarina.
ahead.
Yeah, I just wanted to thank you. Thanks everyone for coming. Of course, it was very useful for us, and thank you for sharing many of your interesting and intriguing ideas. So I believe we now have a lot of work to do for our homework, but indeed it will approve our work. So thank you very much for this opportunity, and we enjoyed, and hopefully see you during some another event.
Hvala,
Yeah,
hvala.
I just want to
Thanks, everyone.
reinforce that we have our email address is probably available, but feel free to shoot something in the chat, and I will check it out. And just connect with us. I mean, our email address is public. Feel free to ask your questions in private email or personal. It's fine.
Well, great. Thank you so much. And yeah, Akil,
Yeah, I just wanted
did
to
you want to?
say thank you in their languages, like Köszönöm szépen and hvala. No, something interesting.
Oh,
Okay.
wow.
Wow.
Örvendek, drágom is the
For
sound overs now.
Oh my God.
For
Akil,
others,
where are you
Akil
from?
said Hungarian.
Yeah, I have a
Thank you
Hungarian
very
last
much.
name. I know it's interesting, but I've been to Serbia and Hungary both. I've been to like
Good.
Niš, Belgrade, and
Uh-huh,
I've been to
uh-huh.
Hungary. I've been to places.
But so cool, and your
Okay.
pronunciation, it's great, I have to say, for
Yeah,
a Serbian part
I know
or
how to say
Croatian. I mean,
like
it's almost the same language.
yeah, I know how to say like nice things about Serbia, like Serbia, država puna zeleninila I predivni prizor. I can say the same thing about
Oh
Hungary,
my
like
God.
Magyarország egy nagyon gyönyörű ország, like it's like the same thing that
Okay.
I memorized for different countries.
Okay,
Okay, great.
speaking of beauty, you guys have no idea what the small town where Sandra is from, she's
Yeah.
working, Mostar in Croatia is just the most enchanting city. You should Google it and you will see it with your eyes. It's a
Well,
fairy
Mostar is in
tale.
Bosnia, right? I've been to
Yeah,
Mostar, the
it's
starting. I've
yeah.
been to
Yeah,
that.
it's
Uh-huh.
just beautiful.
Yeah, it's really
Mostar is
beautiful.
actually in the south of the country, but I live near the border area. So basically, I hold nationality of the both countries. So I'm
Wow.
both Bosnian and Croatian, and the language is pretty much the same. Serbian, Montenegro, or whatever. So we all can understand each other, of course, just the dialect is very different. But maybe this is also a good opportunity to invite you all. There is a great conference in Dubrovnik. It's called DUCOG, or Dubrovnik Conference on Cognitive Science. So it's happening once per year, so every year in May, I think. So if you happen to find yourself there, just shoot me a message or something like that. I would be happy to meet.
Naya's asking, what's the enchanting town's name again?
Aha, Mostar. Mostar, but of course you have Dubrovnik, you have Split, and those are coastal cities, and they are so beautiful. So
Yeah,
I advise
Croatia.
you to travel through this southeastern part of Europe.
Yeah, it's
Mostar.
really
But the
beautiful.
climate in Mostar like changes so drastically. Like in the morning, it was like super cold, and in the evening, it was like in the afternoon, it was really hot. I've been
Yeah,
to Mostar.
no. Now, like during the springtime, we can have those kind of changes, but usually it's very hot, and over the summer, it can easily reach like 40 degrees. So many tourists, when they come, they are shocked. So you should be prepared. And when I was younger, I traveled a lot, and I even went to Egypt and to India, and all of my friends, they were asking me, "Oh my God, it's so hot! How you are going to survive?" I was like, "Come on." Like here it's just 40 degrees, so it doesn't make any difference. So it's super hot. Be prepared, and rarely we have a snow. But yeah, you are all invited to come. And of course, Budapest, I believe it's one of the most beautiful cities in Europe, and I enjoyed living there. So just come over.
Yep, I agree. Zoltan, did you want to?
Yeah, yeah.
Thank you. Well, I cannot really finish with nicer words. But yeah, Sandra said, you're all welcome. I still think that Mostar is more beautiful than Budapest,
Should be
but we
exchange.
can argue on that. We can
Okay.
arm wrestle on that.
Well, thank you for sharing that, and Akil for saying, starting this wonderful ending, which, yeah. So, thank you so much. Maybe we'll see all each other in this beautiful settings, and yeah, I hope to hear you all soon again. So, I'll close the room now in 3, 2,
Three,
1.
two,
Bye,
one.
everyone.
Bye.
Thank you.
Our pleasure being here. Goodbye.